So this is the Envoy deep dive session, but what we're actually going to do is we're going to have 4 different lightning talks. And then we'll, if there's time at the end, we'll do general Q&A. I think there's some people that thought that this was another repeat of my talk yesterday, which is not. So hopefully that's what people would like to hear. And I think in the interest of time, let's just get going. So our first talk is going to be Andre from Booking.com.
Hi. Okay, thank you. Hi, I'm Andre. I'm working at Booking.com, and I've been deploying Envoy between our services at Booking.com. And this presentation is about interesting stuff that we find while doing this deployment. The first story is about a new service that we are testing out in production. These are statistics that service owners were using to monitor their service. As we can see in this dashboard, there are absolutely no errors, and we are getting some requests, so everything seemed fine. But when we looked at the statistics generated to Envoy from the client side, what actually happened was that 2 hours after we started the test, there was another broken instance that started serving requests, and all those were errors. So half of the requests were okay, half of them were errors. I don't know how we could find out without if we didn't deploy Envoy before. In another case, we had an old HTTP client that didn't support persistent connections, and it was making requests across data centers. And this is what happened with the connect time after we deployed Envoy for this service. In another case, we had a service. It was deployed into data centers. Everything was working fine in the first data center. In the second one, some requests, only some of them, were timing out when we tried to do the migration. After a bit of investigation, what we found out was that the requests that were timing out were actually 4 times slower in this data center. In the first one, everything was working fine, the same requests. And this was due to a misconfiguration of the service. It was using a database from the first data center in the second one. And the requests that were timing out were making multiple queries to the database for one HTTP request. We also didn't have any idea that this was happening before. The fourth story is about an old service that we tried to migrate. We didn't know what timeouts to set for it, so we said, okay, let's look at the old timeouts. And this is what we found. It seemed to support timeouts, but all of them were set to 0. The good news about this finding is that this service was running like this for more than 1 year in production, and nothing bad happened, so that means the service was very, very stable. This is the best story. This was happening in the development environment. Over time, we heard reports from users that things are slow in the development environment, but we had no visibility to know where to start looking, at what to start looking. And after we deployed Envoy there, we realized that most of the services were experiencing like latency spikes every minute at the beginning of the minute for a few seconds. After a bit of investigation, what we found out, there was this cron job, scheduled like this, minutely, on all the development machines. This part script, before doing what it was supposed to do, it was connecting to a configuration service. That configuration service was used by the rest of the infrastructure. And that's where the slowdowns were coming from. The good news about this finding is that NTP seems to work very well in our development environment. This is how we pulled out the migration. We asked service owners to either do all the changes by themselves. Some of them chose that. Most of them chose to pair with us and do all the changes together. And some of them chose to let us do all the changes. And this was mainly for services that were in maintenance mode that nobody wanted or knew how to touch. And the main concern that were raised by our colleagues when we tried to deploy Envoy in production were about the resource uses, like is Envoy going to eat up all my CPU or memory? Another concern was about latency increase. Are the requests to Envoy going to be slower compared to the requests without Envoy? And for both those cases, we just collected the actual data and looked at the data, and we realized that this is not a problem for us. And another interesting concern was that while we were doing the migration, we had a service that had some clients, but not all the clients were migrated. Or we had a client that was using multiple services, and not all the services were migrated. And each of them was waiting for the other to finish the migration. That was it. Thank you. Or should we do them at the end? Or do you have any questions? Yes.
For monitoring, what was your monitoring stack for actually seeing the insight coming from the system?
In what case? Or you mean for with Envoy or before?
For things like detecting the cron job and seeing the slowdowns, did you see that through your any sort of monitoring?
So we use statistics from Envoy in all those cases. Where we found problems, we use statistics from Envoy and we send them to using statsd, to statsd exporter, and then to Prometheus. Yes?
Which services you already migrated and what time it took for in terms of that days efforts?
It depends. I think we just passed half of our services, like also number of servers and services. We are just at 60–70% now. Actually, migrating one service is not that hard. I think it's something that you can do in maximum 1 hour. But what we spend more time was to also discuss with the service owners and try to make them understand, and that's where we spend more time, because we didn't want to do a change like just do the change like this without also talking with the colleagues and everything. So that's why, I think it took 2 months so far for us, but 80% of the time was more talking.
Cool. Thank you very much. All right, we have Doug.
Thank you. Hi, I'm Doug, and I'm going to talk about building a service mesh with Envoy at Squarespace. So I thought starting with a little bit of context would be helpful. So if you go back to 2013, we were pretty small, less than 50 engineers, even less working on infrastructure. And it's a typical story. We're building whatever works with a monolith. And, we grow a little bit more and find out that, we're kind of dealing with too much firefighting. The monolith is kind of inflexible for our needs. 2016, we start to introduce microservices, try to build things to be scalable and reliable. Last year, we have teams building even more microservices, working independently full stack. The big thing is that we're introducing self-service infrastructure with Kubernetes. So a little bit about our platform. So we started building our microservices platform in 2014. We're building Java API servers, running on virtual machines, and using console for service discovery. We're using a service client library based a lot on the Netflix open source software stack. So that's things like Hystrix, Ribbon, and RxNetty. And now we have in progress this migration from VMs to Kubernetes. So a little bit about our setup with console. So we have our services, when they come up, they announce their presence in the console. And then a service that's requesting those has its client library there that's running, requesting service instances out of console, and then performing the load balances against the healthy and available service instances. We have console set up for cross data center replication using its built-in gossip protocols. So why did we want to pursue a service mesh? I think one of the big things was that we wanted to take that functionality that we had in our client library that's using the Netflix open source stack and take that and move it out of that library so that it's its own process in a sidecar. And that would give us some advantages like being able to configure and update that process independently of the application that it serves. We also were interested in having advanced operational control through APIs that work with that sidecar. We were looking to have improved observability, and we really wanted to open the door to support service development in multiple languages. Historically, everything in production was Java, but as the company has been growing, there's been a desire to use other languages in production, and it's already started to happen, so we were really kind of behind the curve and wanted to support those other languages. So we chose Envoy for our service mesh. Some of the things that we liked about it was that it's built to run as a sidecar. It can proxy ingress and egress traffic. Really liked the dynamic configuration API. So we could use that to provide service discovery information and do things like change the routing table and circuit breaker configuration on the fly. And we thought this would be a really big upgrade in our capability as operators. So how did we go about trying to incrementally introduce Envoy into our stack? So what we came up with was introducing this new service that we're calling Mesh Discovery, and that's really going to be put in place to front console. And then that uses Envoy's XDS API, the version 2 API, to provide streaming updates to Envoy, which is running as a sidecar in our Kubernetes pods. So our services that are coming up, they're still doing the same thing they've been doing before, announcing in the console, and then Mesh Discovery is just pulling that information out. So I wanted to talk a little bit about how we're using this XDS protocol with console. So Envoy, when it starts up and performs cluster discovery, CDS request, that goes to Mesh Discovery, and that just maps over really easily to requesting from console's catalog to just get a list of the services. So we get that list back from console, and one of the things that console has in their API is what they call an index. And that represents a point in time and can be used for long polling to see if there's any updates. So we're simply taking that value that we get in the index and passing that as the version info back to Envoy. So after Envoy has gotten its initial list of clusters, that stream from Envoy to Mesh Discovery, that just remains open and idle. In the background, Mesh Discovery is polling console, continuing to see if that catalog list has anything newer. So we're just asking console, do you have anything newer than that index 1, 2, 3? Once console has some new data, it sends that back, the index is updated, and we just pass all that information back to Envoy with a push update and set the new version info number. So that's how it works for CDS. The other parts of XDS are pretty similar. So we're using EDS, and that's the same exact strategy, just instead asking console for all of the available endpoints for a service instance. And then for RDS, right now, we just have a very simple routing table that's just matching a header value to a cluster name. So I talked about observability, and this screenshot is an example of one of the things that we're currently working on. So we're trying to find a very visual way with Envoy to show the listeners that Envoy has open over on the left, and then all of the clusters that it's recognizing, and then finally all of the endpoints for each cluster. And we can dynamically set the colors for the boxes based on various statistics. So future work for us includes trying to build out more orchestration features into our new discovery system. So taking that Mesh Discovery component and really building it up to be the control plane that we need. So we want to harness that XDS API so that we can push updates and make traffic routing changes on the fly. We want to build APIs into that system to abstract away the common operations that we want from our service mesh. And we want to build a dashboard for operators so that they can see all of these metrics and also be able to go in there and quickly make changes for the really common everyday operations. That's it. Thank you. Okay, time for questions.
So quick one, when your Envoy proxy is calling your Mesh Discovery service, what information is it presenting to the discovery service to identify itself? IP address or?
Yeah, so we get the host information from Envoy, and so you can configure Envoy with what cluster it's in and like a name for that instance. So we're receiving that information, but right now we're not doing anything with it. But I think it's definitely something that we'll take advantage of in the future. So we're using Prometheus, so we're just going to scrape everything that Envoy provides. For us, the really key ones are request rate, like response codes, 500s and latencies. Those are the big ones for us. And I think, in the future, we'll care more about exactly where is this traffic going and having good ways to drill down and answer those questions. Okay.
Thank you so much.
Thank you.
All right. Gimbal. Thanks. Yeah, great.
Good afternoon. Today we're going to be talking about Heptio Gimbal. My name is Ross Kukulinski. I'm a staff systems architect at Heptio.
Hello, I'm Hiro, engineer of Octavio.
So we've been collaborating for a while now at Heptio and Octavio, and we announced Gimbal last week. Gimbal is a multi-cluster, multi-team ingress load balancer built on Kubernetes and Envoy and Contour. Now, before we get into all the technical and architectural decisions we've made, I think it's important to understand Octavio and Yahoo Japan's infrastructure and why we went ahead and built this project.
Okay, let me talk about Octavio and our background quickly. So Octavio is US subsidiary of Yahoo Japan. We cooperate with Yahoo Japan on core infrastructure from data center to private cloud. We support over 100 applications running on 85,000 physical servers, 10 data centers, and over 50 OpenStack clusters. We've started using Kubernetes as well, and the number of Kubernetes clusters is growing rapidly. In such environment, our challenge is application delivery. Application delivery at scale is key to our business. We needed faster service discovery and canary deployment capability that provides instant rollback and performance observability. Gimbal enables our developers to address these challenges and helps to increase their productivity and optimize system performance. We'd like to share more about Gimbal architecture, and I'd like to invite Ross back up.
Thank you, Hiro. So Gimbal is meant to be deployed to one or more Kubernetes clusters in front of your infrastructure. So this is your load balancer. You don't necessarily need a cloud load balancer, or if you're on-prem and you wanted to have something like a Google or Amazon cloud load balancer, you could deploy this to your infrastructure and get similar behavior. And one of the interesting things, so there's three key components to Gimbal. Number one is the service discovery. We need to pull information from upstream Kubernetes and OpenStack clusters and inject that information into Gimbal so that developers have a unified way to configure their routing rules across all of their services that may be running in different clusters. Number two is the routing capabilities. So Heptio earlier this year we built Gimbal, last year we built Gimbal, which was the first part of our collaboration. And Gimbal is an Envoy-based ingress controller for Kubernetes. What? Sorry, Contour. And then the third part is the monitoring suite. So let's dive into some of these things. So the first thing was service discovery. With Octavio, and we've noticed this with a lot of our customers, development teams have a namespace in every cluster, and they may have applications deployed across multiple clusters. Some of it might be Kubernetes, and some of it might be OpenStack. So we needed a way to discover those applications running in upstream clusters. Now with Gimbal, what we do is we discover those in Kubernetes. We are just grabbing the services and endpoint objects from Kubernetes, as well as the service and endpoints, and we're injecting them into the Gimbal cluster. For OpenStack, they don't have service and endpoints. So we're translating the Nova API, which gets us our virtual machine IPs and ports, and the OpenStack LBAS, so their load balancer as a service APIs in OpenStack. And we translate those to service and endpoint objects in the Gimbal cluster. So as a developer, you can do kube control get services or describe services, and it shows all of your services across all clusters. And we're also applying metadata from which clusters they came from, so you can see where your traffic is coming from. The next aspect is the routing and policy. So we built Contour, which is a Envoy-based ingress controller for Kubernetes. It's a drop-in replacement for existing ingress controllers. So one of the things that we found is the dynamic API in Envoy is much better suited for the dynamic environment of Kubernetes, where we have lots of services and endpoints coming and going. Being able to hot reload the routing configuration on the fly is key. However, for those of you that have been working with Kubernetes, you may have noticed that the Kubernetes Ingress API by default doesn't really cover all the needs that many organizations need. Two key issues. Number one, it's not multi-team compatible. So any team that has the ability to create an ingress object in a Kubernetes cluster could potentially create routes or new domains that impact other teams. That's not okay in businesses. The second one is the default Ingress API doesn't support any advanced features like weight shifting or load balancing or sort of cluster cutoff. And it also doesn't support multiple services per route. You can only have one service per route. And in some of the Ingress controllers have gone through annotation. They try to inject all that into annotations, but we wanted to have this built natively into a new API. So we have put together a design for a new Ingress route API that we're going to be using as Contour. So Contour will be able to speak either the current Ingress, or you can switch to this new Ingress route design. We're about to start development on this. So we're really excited about that and would love to talk more about that, but don't have time today. The last aspect is observability. At the scale that Octopio is running at, they need to have insight into where the traffic is going, where are the errors, which routes are having problems, or is it localized to a specific service across all clusters, or is it a single one cluster that's having issues? So Gimbal, when we have an out-of-the-box monitoring system built on Prometheus, Grafana, and Alert Manager, and we include pre-built dashboards. Now these will be evolving as we move forward with the project as we learn more about operating this system at scale. And that really gets us to the next piece. Where are we on our roadmap? So last week, we launched this project. The two key things was the OpenStack Discoverer and the Kubernetes Discoverer. We are leveraging the current Ingress v1 beta API for managing this, and we have some initial documentation and dashboards. Looking forward to this summer, we'll be rolling out the Ingress route integration, or Ingress route CRD into Contour, which is then used in Gimbal. So that'll give us multi-team and advanced routing capabilities. The other thing is Octopio is going to be going to production with this. And that means that we have to test this to meet their performance standards, which are quite high. So Octopio and Heptio will be collaborating on performance testing of Gimbal, which means that we're testing Contour, which means we're testing Envoy to make sure that we can handle all of this at scale. Now looking forward to this fall, version 0.3, one of the biggest sort of drawbacks for some companies with Gimbal is right now Heptio Gimbal requires every pod or virtual machine that's going to be routed to needs to have a routable IP from the Gimbal cluster. So if you're using an overlay network in your Kubernetes cluster, this isn't going to work for you yet. But we know this is a deficiency for organizations that may be running at some of the cloud providers. So that's an aspect that we're working on. The other piece is being able to deploy this without a hardware load balancer in front of it. At launch, Octopio will be having hardware load balancers in place, but looking forward, there's really no reason that we need to have those hardware load balancers. One of the things that we could do is we could leverage something like MetalLB or VRRP integration to allow the Gimbal clusters to broadcast the virtual IPs that they can serve traffic to. And that way you can easily remove the hardware load balancers and you truly have a cloud-native load balancer running in your bare metal infrastructure. Or if you're running across multiple clouds, you can still have a consistent load balancing platform that will allow you to operate across multiple Kubernetes clusters, no matter which cloud you're in. And that's it. Thank you. And I think we've got time for 2 questions. Yes, sir.
How do you plan to canary configuration changes that change routes or traffic policies?
Can you repeat your question? Because I'm going to repeat it too, but I just want to make sure I fully understood.
Yeah. So like when you're making changes to your routing policies, like at my egress level, this is a really powerful configuration that can easily black hole my traffic or route it somewhere I don't want it to go. So it's good to canary those changes before they're pushed to the rest of the cluster.
Great question. So the question is, if we're doing these advanced routing capabilities, right now if you make a change, your traffic can disappear instantly. One of the things that we've done with this Ingress route design, and we'll be doing more talks in the future about this, and definitely happy to talk afterwards, is we're tracking Ingress and treating it sort of like DNS delegation. So you have your root domain, or your root ingress, And so I own www.heptio.com and heptio.com. And maybe I am responsible for a main landing page, so I have that in my namespace. I can delegate that to, /blog to the marketing team. And inside their namespace, they'll have another ingress object that they manage. And if they can delegate to themselves, they can have a blue-green ingress. So they have their top level that manages inside their namespace. It can have a pointer to that actually serves the traffic, and it points to 2 other ingress routes. So you switch one, if your traffic black holes, you switch back. One more question. No more questions? Oh, there we go.
Is that HTTP only, or are you going to do TCP, SNI, something that...
So we do HTTP and HTTPS. In terms of, so we're focusing on L7 load balancing at this point. May we eventually move lower in the stack and support L3 or L4 load balancing? Maybe, but it's not a priority today. And if that is something that you are interested in, come talk to me. Great, thank you.
Spire and Envoy.
Thanks, Matt. Just to level set, quick show of hands, who here today is using TLS with Envoy right now? Okay, so for the 4 people who put your hand up, this talk is for you. For everyone else, shame. TLS seriously is quite hard. As is advancing slides, Matt. How do I do that? Just press enter. Got it. TLS is hard, and hopefully Spire can help you make it easier if it's something you're trying to do. So Envoy supports MTLS out of the box. It's a pretty neat feature. It's used really for 2 reasons. One of them is confidentiality. That's usually what you think of when you hear MTLS or TLS. It encrypts data on the wire, but the other thing it gives you is identity, because you need to establish the identity of each of the 2 connecting parties. The way you do that is with asymmetric keys and certificates, that's pretty easy to set up with Envoy. You can stick them on disk, and you can add the relevant files to Envoy's envoy.json. The identity of the service, which is important if you want to verify who you're connecting to, there's different ways that the X509 certificate format allows you to encode it. It can be in the distinguished name, it can be in the SAN. There's different strategies there, and Envoy supports quite a few of them. So it's easy enough to set up. The challenge with all of this stuff, though, is how do you do it at scale? When it's a test environment, it's easy enough to just create these things and stick them on a disk somewhere. When you're in a production environment, first of all, you have new services being added often dynamically and certainly frequently. And then on top of that, you need to be able to rotate these credentials, or you should be able to rotate these credentials reasonably frequently. So the process of manually creating these things and sticking them on disk, quite apart from potentially exposing holes in your certificate supply chain, it also simply becomes cumbersome, and it's something that's quite amenable to automation. One answer to this, which we've been working on at Scytale, along with a broader community, is a project called Spire. Spire stands for the SPIFFE runtime environment, and SPIFFE is a specification that defines the certificate formats in a set of APIs. Spires run as an agent and a server. The agent exposes a thing called the workload API, which a service like Envoy, for example, can call into to retrieve, firstly, its actual identity in the form of a string, and then, more usefully for us, X509 formatted crypto material that it can use to establish an MTLS connection, or for that matter, maybe sign a JOT token or some other case. Because it's an API, it's programmatic, and that means you're in a position now to start automating your certificate issuance, and these things have a ideally short-lived but configurable TTL, so you can rotate these things automatically. The Spire server Excellent. The Spire server maintains a registry of what are called attestation policies, which briefly are the conditions under which a given workload, in this case a given Envoy proxy, should actually be issued issued an identity and issued certificates for that identity. The selector language and the selector types you can use is actually very configurable within Spire, and there's a modular framework for building more. But you can describe this in any number of different ways, including by both by the kernel level information on where the workload is running, say PID or Kubernetes level reference, like a Kubernetes namespace or podspec metadata. But you can also describe the infrastructure this thing is running on. So is the node that contains this kernel running in a particular Amazon security group, for example? Another bunch of talks that go into that in more detail. The identity is for Spiffy is encoded in the SAN, in the Spiffy certificate. Again, a lot more, there's plenty of material on how that's set up and structured if you're interested. The only challenge here with getting this to work with Envoy is Envoy does not know about the workload API. And so usefully there's a tool that is also available on the Spiffy repository called the Spiffy helper. This is basically just a simple script that you run in the same security domain, and usually adjacent to Envoy. It's a sidecar to the sidecar, if you will. And basically what this thing does is it periodically calls into the workload API, retrieves the certificates via the API, and sticks them on disk. It can track the TTL of these things and rotate them as well. And crucially for Envoy, when you rotate your certificates, you need to signal to Envoy that you've rotated your key material, and the Spiffy helper, can do that as well. And then once you have this in place, you now have programmatically delivered key material that's been defined by a policy rather than something that you've had to manually generate and set up. The only thing that remains then is to start applying access rules to this. Again, a rich set of discussion that could happen around that. But if you want to do it very easily within an Envoy JSON file, you just add a couple of lines to describe the SAN of the Spiffy IDs that you want to be able to connect to an incoming proxy. And that's it, except to say there's actually, this slide is very misleading. For one, it references the SDS, which is obsolete now. There's a lot of work to do in this space, but one of the first things we want to do is have a nicer bundling between the XDS v2 APIs and the Spire helper, so that we can do this more dynamically without having things lying on disk in unsafe ways. And plenty of links here if you want to learn more about this stuff, and of course you can come and ask me as well. Thanks. Cool. I think we have time for 2 questions. Awesome, done. Thanks, Pat. Oh, sorry. Mm-hmm.
How do they identify themselves when they say, who am I? What do you use?
So it's actually configurable. This is where the sort of policy language comes in. So it depends on the environment that you're running your workload and Envoy in. So you first of all would use some sort of infrastructure descriptor typically. So that might be an AWS ASG. It might actually be something specific to that machine. So if you have a TPM, for example, with a private key in it, you can sign a nonce and use the corresponding public key to identify the machine. So that's one level. And then within the machine, it really depends on if you have any middleware and how you're doing that. So if you're just running something on Linux inside that machine, you might use a unit like a UID or a GID to identify it. If you're running it inside if that machine is actually a Kubernetes node, there's a plugin that will talk to the kubelet and pull out the podspec metadata and say, well, we're identifying you, is this process that's calling me something that you've scheduled, and if so, like give me this podspec metadata about it. We actually use the API itself is a Unix domain socket. So what Spire is doing when a workload calls that API is it basically interrogates the kernel and says who is the caller of this, and the kernel will give it back a PID and a GID and a few other pieces.
Sweet, thank you. That's great. Cool, thank you again. I think that was the smoothest set of lightning talks that I've ever seen. That was great. We have like 5 minutes, so now we can go into the Ask Me Anything portion. So shoot.
So great stories. And I see Envoy catching a lot of traction as a proxy, and therefore, even on the ingress, I'd expect that there's going to be a lot more feature requests and growing it. What's your vision for Envoy in terms of trying to keep it lightweight and focused start getting into this ingress stuff and, the feature creep can grow and.
Yeah, that's a great question. I think what we're trying to do, and we've held pretty strong so far from a project perspective on this, is to kind of keep with a unified API, so this XDS API. So instead of going and supporting Kubernetes CRDs and like console and the 87 other systems out there, we've kind of set the hard line in the sand, which is that, this is the API that Envoy supports, and if people want to use it, they basically have to write to this API. And in the beginning of the project, I was concerned that that was going to be a non-starter and that people would complain about, why don't you support console or these 7 things? And as it turns out, it's actually become a selling point. And I think people, the APIs, I've been really pleased with how we've evolved them. I think people enjoy actually using them. And I think that's the way that we keep it from getting totally out of control. So if people want to do their custom stuff, they're going to write to the APIs, and they basically have to write their own adapters. From a feature perspective, I think where we see the project going is, kind of the way that I look at it is, my vision is that Envoy will run everywhere, but that no one needs to know where Envoy actually runs. So I think that there's going to be a whole suite of systems, whether it's Contour or, there's 10 or 12 different projects now, and lots of companies that are using Envoy. I see Envoy as a building block that gets used in larger systems. So I think from a feature creep perspective, we're going to do what it takes as long as it fits within the API. But we're not going to go out of our way to support like every different possible use case. It has to be kind of that core use case that is useful to more than one customer, basically.
I could see it going like HA proxy or Nginx instead of really.
Yeah, and that's a constant struggle. And there are things, for example, that I would like to never do. So I don't know that we'll ever implement caching in Envoy, because why would we not use Varnish? Like Varnish works great. Why would we implement a full web server in Envoy? Nginx works great, right? So I think that's where we have to draw those lines.
You said the internals, you may not have chosen C++, but I've read that it was chosen to be consistent with performance. Some blog posts I wrote. What changed, or why do you say that?
Oh, so I mean, there's other options these days, like whether it's something like Swift or Rust or something like that, right? And all of these languages evolve. But from my perspective, when we were in 2015 and choosing a language in an ecosystem, my goal is to get stuff done as fast as possible. And the C++ ecosystem, while not perfect by any means, no tool is perfect, it allows a large number of programmers to get stuff done relatively quickly at high performance. Teasing, no teasing. But I'm under no illusion that C++ is going to last forever, right? So I mean, as some of the tools, again, I think Swift and Rust are both very interesting. And 5 years from now, I personally think that they're going to displace a lot of C++. No other questions? Cool. Well, thank you for coming, and I'll be around if anyone wants to ask any one-on-one stuff. Thanks a lot.